page. This should be completely reviewed. The first one, you don't have to worry about sketching it two-dimensionally. When we have been doing our sketching the interval, we've only been doing it on the number line. So just do it on the x-axis, okay? And then for your second one, you're looking at domain and range. So reminder that domain is where the x's go and the range is where the y's go. All right, so up here you have the open. Remember, parentheses means you're doing an open circle. We're going to do this right on the x-axis, okay? If you did it up or down, it doesn't matter, but you should have open circles at 1 and 2 with a line in between. Remember, this symbol means, the U symbol means that we're doing several pieces, right? So we have 3 different pieces. The square brackets mean that we're going to be doing solid dots, right? So I'm going to make a solid dot at 3 and a solid dot at 4 and connect those dots. And then 5 has an open dot again, so make sure you have an open circle there. Whenever we see an infinity, we know that it's an arrow going off to forever. So we're just going to draw an arrow out like that. All right? So that's that one. Domain and range. Who remembers what domain means? What does domain mean?
What does it mean?
Well, no, what you said.
X.
The x values, right? So remember, I showed you guys kind of box this in. And then you can see exactly where the x values go. Politeness, lack of noise. Let's have level 0 right now, please. Let's have level 0 right now, please. If I need to continue repeating myself, then unfortunately I will have to start giving demerits. Don't want to have to do that. Okay, so we're going between -4 to +5 for our x values. If you want to write it as an interval notation, we're just going to say, let's see, is it open or closed circle at -4? It's closed, so it's going to be a square bracket, and we'll put the -4. And then at 5, is it open or closed? Open, so we're going to put a parentheses with the 5. All right, so that's our domain. Our range is what? Y values, right? So we're going to go up and down the y-axis and see what is the lowest and highest thing. So I think this is the lowest one, right? Kind of a little off. So we're going to go from -3 up to 4. -3 up to 4. So at -3, is that an open or closed? Open. So we're going to go -3 with the parentheses for being an open circle there. And then up at the top, we also have an open circle. So at 4, we'll put parentheses. Okay, what questions do we have on this? Thumbs up if you feel pretty good about this. Sideways or down if you're still stuck. Okay, so you see the people around you who know what they're doing. If you want to ask for help later from someone besides myself, you can do that. Okay, so we're going to go ahead and go to checking your work from yesterday.
Can you go to the checking for understanding?
Yeah. I'm going to pause this for a second. Notice that they have highlighted each section. So the x-axis is what we're concerned about in this one, Rob.
I hear you. I don't multitask.
The x-axis is what you're concerned about on this one. So for the increasing on 4 to positive infinity, that's this part right here. Okay, so they counted up 1, 2, 3, 4. This is 4 right here, right? Let me see if I have I don't know where my writing tool went. Yep, Up there in the basket. Okay, so then the middle part is the constant. So you can see they did constant 0 to 4. And again, we're doing x values. We're not doing y values at all. We're just looking at the x-axis and where are the x values for the increasing, decreasing, and constant parts. Okay, so this part, remember we said even though there's an arrow up here, it's actually going left to right. We always read the graph left to right. So we're going from infinity, negative infinity, to 0. So that's how it shows here. From negative infinity to 0, all of these intervals are open. So you have an open interval here, open interval here, open interval for the arrows. And then this one is open as well, but they could have written it open or closed. I would have accepted either one for that. Okay. So function g of x, we're looking for the x values again, where g of x is 0. Remember, g of x equals 0 means it's the y value. So these values are going to be on the x-axis. So where does it hit the x-axis?
G of x equals the y value. What that mean?
Right, so I was just saying that g of x is the same thing as y, right? So we're looking for where is y equal to 0.
G is y. Oh, G is y?
G of x is the same thing as y. So on the graph, we're looking where is y equal to 0, and those x values are these 3 spots here. So my answers are x is -3, x is -1, and x is 2, because there's 3 spots where it crosses the x-axis. Okay? Relative minimums. They have the relative minimums highlighted in yellow. By the way, for today's lesson, you have highlighters in your little crates. So as we go through, I'm going to point out where you need to be highlighting. Okay? So the minimums are highlighted in yellow. So we have one at, I put like -2, -35, so I made these like points. But when it's talking about minimums and maximums, we are usually thinking about the y values, right? Whereas this one, we're focused on the x values. So for our maximums and minimums, we have -2 to -35 at 0 to 0, right?
Do we have to write
I prefer it as a point. Okay, otherwise, the other way to be doing it is, because I feel like it doesn't make a lot of sense, but when y is -35 and y is 0. Okay.
You said the y value.
Right, it gives a more precise location when you're making it a point. Okay. Then the last one, they put 32. Don't worry about it. This is just estimating. So I said 30. A lot of people's papers I saw said 30. Some people put 35 for that one as well. So we're estimating, right? It's close to 30, 32, something like that. Okay? So we have 1,32, or you could put that when the y value is 32, that's the highest point on the graph. Remember, these are relative or local maximums and minimums.
I'm not understanding.
What I wanted you to make sure that you remember is the rate change. So when you're doing the average rate of change,
What is that?
remember that you're doing the change in y over the change in x, or you have the function at one point minus the function at the other point over the subtraction of the x values. Okay? So this function is called g. It's not called f. This function is called g. What are the x1 and the x2? This function is called g. What are the x1 and x2? Thank you. Okay, or 1 and 6. Okay, I've got two x values that I'm putting into the equation. Okay? And you will see that the first time they put it in, it's going to be 6 into each x spot. So we're putting 6 squared minus 5 times 6 plus 8. So there's 6 into the equation right here. Yes, Tina? For success, say that I can, these are your goals, I can determine where a graph is increasing or decreasing. I can determine positive or negative portions of the graph. When they say portions, they mean intervals. And then the third one is I can determine points of interest on the graph, including maxima, which is plural for maximum, minima, which is plural for minimum, and x and y intercepts, which we were just talking about. Okay, so first of all, what do you notice and what do you wonder? And then I lost my projector. Okay, take a moment and see if you can write one thought about what do you notice and what do you wonder on that bottom part. Thinking about those graphs, they're different. The graph is the same, but the coloring is different, right? So that's kind of what you want to be thinking about. Actually, maybe that was something that somebody noticed. Is that something that somebody noticed? Okay, great. Got a couple of people that said that. Okay. So the graphs are the same. They actually said this up here. Same graph, different colors. And then anything else? Raise your hand if you have something else that you noticed.